Moving right along with our next section, 4-3 from the textbook, writing equations in point-slope form. So point-slope form is the third and final form of a linear equation that we'll learn. And this one, as the name suggests, you need to know one point and the slope of a line in order to write an equation in point-slope form. So if you recall in the previous section, we looked at if you know one point and the slope, you can plug them in to y equals mx plus b to find b, to get the equation in slope-intercept form. But this is an alternate way to do it. So given one point, given the x and y coordinates as numbers, and a slope m as a number, x is the input variable and y is the output variable, we can write an equation y minus y1 equals m times parentheses x minus x1. And interestingly enough, this is actually a variation of the slope formula. Remember, our slope formula is m equals y2 minus y1 over x over x2 minus x1. So we multiply both sides by this part here, then we move it up on the other side, then it looks just like this. And now we're only plugging in a number for x1, y1, and we're leaving x2, y2 as a variable. So this is actually the equation of a line. It can be rearranged and put into standard form. It can also be rearranged and put into slope-intercept form. So if you're trying to find the equation in slope-intercept form, the old option was to plug in and find the b using y equals mx plus b. So you could plug in y, x, and m to find b. The new option is to write the equation in this form and then rearrange it and solve for y. Okay, so some problem-solving tips. In order to convert into slope-intercept form, just take that equation on the previous page and solve for y. So distribute into the parentheses, and then add to both sides whatever you need to do. If you want to convert these into standard form, remember what standard form is. I've written here as a reminder, ax plus by equals c. So you need to get integer coefficients. A, b, and c all need to be integers, which means no fractions and no decimals. We also need to move the variables, the ax term and the by term, to the left-hand side of the equation by adding or subtracting them over to the other side. And finally make a positive by maybe divide everything by -1 if you need to. So you can convert any of these equations into standard form or into slope-intercept form. When given a point and the slopes, this is what I was saying before, you can immediately write the equation in point-slope form, or you could do it the old way where you solve for b first. And then the last thing I want to remind you is, when using point-slope form, I'll write it here for reference, y minus y1 equals m times x minus x1. The x here and the y here stay as variables. This is the number one problem I see, is that students plug in numbers here and here. And you don't want to do that. This is the actual y variable, the output, and this is the actual x variable, the input. The place where you're plugging in numbers are here, here, and here. Okay, let's do some example problems. Write an equation in point-slope form given this point and this slope. So this should be super easy. We're filling in the equation y minus y1 equals m times x minus x1. So we write y minus a -5, which becomes y plus 5, equals m times, not m though, oopsie, scratch that out, sorry. We actually have an m value, -1/2 times x minus the x value, and the x value is 3. Okay, so that's my equation. Y plus 5 equals -1/2 times x minus 3. Next one. Y minus y value is 2 equals m, which is 1/5. X minus a negative becomes positive, and my x coordinate is 3/4. Okay, so just writing the equation in point-slope form is actually really easy. You just fill in the x and y values in the x1 and y1 locations here and here, and the m right here, and you're all set. Now converting them is a little bit more work, so next we'll try that. Convert each equation to standard form and slope-intercept form. So the first one, let's try converting to slope-intercept form. So I'm going to distribute, and I'll get y minus 3 equals 4x plus 20, and then I'll add 3 to both sides. And so my equation is y equals 4x plus 23. So this is the answer in slope-intercept form. The slope is 4, which we already knew because the 4 is right here, and the intercept is positive 23. So slope and intercept. Now to convert this equation into standard form, we need to move all the x and y terms to the other side. So let me start with y equals 4x plus 23. I need to move the x to the other side, so I'll go minus 4x minus 4x. Those cancel. I now have negative 4x plus y equals 23 from here. Now I need to change the sign because my leading term is a negative, so I can multiply everything by negative 1 or divide everything by negative 1. I'll choose multiply by negative 1. That effectively changes all the signs. So I get a positive 4x minus y equals negative 23. You have to remember to do it to both the left and right side of the equation. So here's standard form, here's slope-intercept form. Okay, for the next one here, I've got fractions. So if I want to convert to standard form, I have to clear the fractions. If I want to convert to slope-intercept form, I don't have to clear the fractions. So let's go ahead and do them in the same order. We'll do slope-intercept first, so I'll distribute here. So I have y plus 2/3 equals negative 1/4 distributed in gives me a negative 1/4 x plus 1/4 times 5 is 5/4. Let me just pause and mention real quick, when I'm doing these example problems in the videos, if you're watching the video right now, what I really recommend you actually do is, as soon as the slide comes up with the example problems, is pause the video and try to solve these problems in your notes yourself, and then watch the solution and check and make sure that's what you did. Or if you really don't have any idea or you're not sure, you can go ahead and just watch them and go through. But it's good practice to try to solve these yourself and then check. It's a lot better than just copying without thinking about it. Okay, so continue. To get y by itself, I want to subtract 2/3, subtract 2/3, and I get y equals negative 1/4 x. Okay, 5/4 minus 2/3. Oh, what a nightmare. I need to get a common denominator, so I'm going to multiply this one by 3/3. I'm going to multiply this one by 4/4. So my common denominator is 12ths, and I have here 5 times 3 is going to give me 15 minus 2 times 4 is 8. So 15/12ths minus 8/12ths. 15 in the numerator minus 8 is plus 7/12ths. Okay, so there's my equation in slope-intercept form, and now I want to go into standard form. So again, let me write it down. Y equals negative 1/4 x plus 7/12ths. I need to have no fractions or decimals in standard form, so I'm going to multiply the entire thing by whatever number will clear the denominators. I could multiply by 4, that will clear this denominator, but it wouldn't clear this one, so I need to actually multiply everything by 12. So both sides, right? Both sides. So 12 on y on this side. If I distribute this in, 1/4 times 12 is negative 3x. This 12 and this 12 reduce, and I just have a 7 right here. Okay, now I need to move the x's over, so plus 3x plus 3x. So I have 3x plus 12y equals 7. And I've got x and y on the correct side. I've got first term positive, and I've got all integers. So these equations in point-slope form, as you can see, the point was 5 comma negative 2/3. It's all good. Now, I just realized I want to say one more thing. So on this next slide, I'm going to show something. If you're actually given an equation, say y minus 4 equals 3 times x plus 1/2, and they ask you what was the point that was used and what was the slope that was used. The slope is easy. You just look right here. That's the 3, right? Slope is 3. But the coordinate point that was used, because the formula has negative signs in it, right? It's y minus y1 equals mx minus x1. Because this is a minus sign in the equation itself, the number that you see here is actually the opposite sign of the coordinate. So this is actually a negative 1/2. And if you think about it, by doing x minus a negative 1/2, that's how we got this plus sign in the first place. And then likewise the y coordinate, even though you see y minus 4, the coordinate is actually a 4 because it's y minus the coordinate. So the y minus 4 means that y1, or the coordinate point, was a 4. So just be cautious with those minus signs. In the equation there's minus signs, which means the point is opposite of what you see. Alright, that's it for these. I hope the examples made sense, and if not, let me know.